Hey guys, welcome back to Longevity with Natalie Nidham. I'm so happy that you're back with me today. We have a fantastic episode for you, as always, with a repeat guest this time, Martha Carlin. And we're going to be talking about the relationship between the microbiome and neurodegenerative diseases and a whole bunch of other related topics. But as always, want to thank you guys for being here. Would love to invite you to visit natnidham.com, sign up for the newsletter because we're going to be ramping things up over there over the next little while. Lots of exciting things coming down the pipes. All right, let's talk about this episode. Is it possible that the root cause of Parkinson's disease might just be hiding in the gut? In this longevity podcast episode, I am joined by Martha Carlin, founder of the BioCollective and BiotiQuest, to explore the role of lipopolysaccharides, LPS, cellular debris from harmful bacteria, in Parkinson's disease and other chronic conditions. We dive into the importance of the microbiome in overall health, the connection between constipation and Parkinson's, and the potential impact of probiotics in mitigating LPS-related issues. We also explore the benefits of cold showers, cold plunges, cryotherapy in signaling microbes, and the potential of AI in accelerating learning and understanding the complexities of the microbiome. Now, Martha Carlin has become a friend. I think it's her second time on the podcast. She's actually a former business woman who turned expert and turned citizen scientist after her own husband's diagnosis of Parkinson's over 20 years ago. She has emerged as a pioneering force in microbiome research and Parkinson's disease studies since her husband's diagnosis. And she's surrounded herself with experts and scientists who are supporting and doing the work that she is kind of spearheading. After teaching herself chemistry, physics, biochemistry, and microbiology, she founded the BioCollective in 2015, creating one of the world's first fecal banks to accelerate microbiome research, and later developed BiotiQuest, a line of innovative probiotics. Her groundbreaking work, which includes the development of Sugar Shift, a probiotic formula initially created for her husband with Parkinson's disease, has led to collaborations across multiple scientific disciplines, speaking engagements at prestigious venues, including the White House 2016 Microbiome Initiative. Now, to shop BiotiQuest formulations for yourself, all you have to do is go to biotiquest.com and use code NAT15 to save. And I should add that you don't have to have a neurodegenerative to get benefit from her probiotics, and you'll learn all about that in the episode. And now let's jump into the episode. Hey folks, just a quick reminder that all of the information presented in this podcast is for information purposes only. No medical advice, no diagnosing, no treatments suggested here. Before you try anything that you hear about or learn about here, make sure that you check with your medical provider. Welcome to the show, Martha Carlin. It is such a pleasure to have you here. Thank you so much for taking the time.
Thank you for having me back. I so enjoyed the last episode, so I can't wait to talk to you again.
Yeah, well, it must have been good because both of us have been looking forward to this, and it's been 2 years. Yeah. So, folks, we'll put the link to the first episode in the show notes. That was an amazing, that episode was amazing and, revelatory in many ways. But I would encourage you guys to go back and check it out because that's where we go into a bit more in depth in terms of Martha's story and what brought her to do what she does today, which is very different than what her career was originally, right? You were a business person. Now you're like the Uber researcher in the Parkinson's sector, interfacing with the top researchers in this space, really looking for answers beyond what's being provided to people, right? And I think what I want to say at the beginning of the podcast is, what, guys, whether Parkinson's is something that is affecting you either directly through a loved one or someone the information in this episode is relevant to everyone because what Martha's going to talk about is a hypothesis and an approach to the microbiome that may preclude many of the diseases of aging that, we're still trying to get on top of, right? So we're talking about diabetes, which at this point, I don't know what the percentage is, but the overwhelming majority of North Americans are pre-diabetic, right? And now we're starting to see it in little kids, never mind in adults. So I can't even imagine if it starts that young over the years, how that's going to show up in later years. But people with Alzheimer's, but also irritable bowel disease. And this includes people with Crohn's and colitis and IBS, right? Irritable bowel syndrome that is highlighted by constipation or diarrhea or an alternate between the two, and even things like MS. So I think by the time I've mentioned all of those different conditions, there's a really good chance this could be relevant to you guys. So, Martha's going to lead us through a new hypothesis, some really fascinating research. We're going to talk about also how the probiotics that she's developing and has developed may fit into this picture preemptively and even as, part of a treatment protocol for different things. So this is going to be chock-a-block full of stuff. And also we're going to talk about LPS, which I only like because who was it? Is it Peter Attia that called them little pieces of shit?
Oh, I like that.
which is a really funky term for little lipopolysaccharides. So whatever it is, LPS stands for something you do not want. So Martha, that was a really long introduction. I apologize. But the last thing I'll say is that Martha has a very personal interest here because her husband was diagnosed with Parkinson's. How long ago now?
22 years ago. 22 years ago.
Yeah.
And then since we first talked, I think he was still having some lingering effects from long COVID. And we've also been able to see some of the overlap in this LPS related stuff with the long COVID symptoms as well. So
right. Yeah, I forgot to mention that. So long COVID, this is another one. So what we're really talking about here is getting to the foundation of what could be driving these issues systemically. And I think that you'd have to be a bit nutty to think that Parkinson's starts, ends, and only happens in the brain. There has to be other stuff happening in the body. And this is true for pretty much everything else. I mean, type 2 diabetes, maybe you could be convinced that the pancreas really is the driver of the dysfunction and, insulin resistance, that kind of stuff. But I think with every passing minute, understanding that the microbiome has everything to do with everything that's happening in the body is probably one of the most important takeaways we can take here.
Yes. And like for me, I started the BioCollective almost 10 years ago. And that was not just to look at Parkinson's, but to look at fecal samples across the population and to stop really thinking about things as single diseases, but to see what's happening in the system. And, along the way, really learning that the number of genes and gene functions that come from the microbiome is 200 to 300 times more than the human genome. So we're really much more microbial than we are human. And what goes on there is really what sustains our life.
Or not.
Or not.
Yeah.
Or, sends us down the wrong pathway.
Okay, great. So that's a great place to start. So really this is what we're talking about is the microbiome. So where do you want to begin with this, Martha? Because I know that, central to our conversation, we're going to be talking about this new hypothesis around how lipopolysaccharides or LPS are intricately involved in this process. But maybe we want to talk about number one, what are they? Where do they come from? Is there anything we can do not to get LPS or not to accumulate LPS? Like these are the things people want to know. So let's start at the beginning and maybe start to understand how does this LPS molecule really get introduced into the gut and then go from there.
Sure. So LPS, lipopolysaccharide, that's a long name. It's also known as endotoxin. Okay. And, maybe that's a simpler term to use, endotoxin, because you get immediately that it's a toxin. So you have gram-negative and gram-positive bacteria, and typically in the body you have both of those, and you want some kind of homeostasis. They keep each other in check. But elevation of gram-negative bacteria, so their cell wall is made out of these lipopolysaccharides. So as they grow and you have a growth curve where they're growing and then some die off. Anytime you have a die off of those gram-negative bacteria, the LPS is basically the cell wall components of this, or the cellular debris.
Oh, so it's waste product.
So it's waste product. It's cellular debris from the gram-negative bacteria. And it's highly inflammatory. And, I discovered, well, I didn't discover it, but in looking in the literature, I found this connection to a litany of diseases where they use lipopolysaccharide or endotoxin to induce the symptoms in an animal model. So that was Parkinson's and diabetes and Alzheimer's and, all the litany of things
IBD,
that you listed,
right?
IBD. And so it's a highly inflammatory molecule. So you don't want a lot of it. You can also get it through food. You can get it through, so a lot of our, even enzymes or pharmaceutical products, things are grown in recombinant E. coli, and E. coli is a well-known LPS producer. So there are, in the manufacturing processes, there are basically screening that they're supposed to do to ensure that the endotoxin level is below an allowable amount. So you can produce them endogenously, but you can also consume them off of foods or through, a supplement or a medication or something that has actually been produced in recombinant E. coli.
So recombinant E. coli here is the bad guy. And so are there specific foods that you can think of that people need to look out for? Is this something like, I don't know, I mean, again, I have no knowledge of this. So is it certain types of packaged foods? Like, do we find it naturally occurring in whole foods?
Well, if I were to really think about, like a lot of times people think about fresh packaged foods as being healthy. Mm-hmm. Or, salad packs and things like that. I think some of those are probably the more dangerous foods when it comes to that. We use a lot of gray water in farming irrigation. And of course, that's going to have E. coli in it. And we see these E. coli outbreaks periodically with, packaged salad mixes or sometimes with meat, you'll see an E. coli outbreak. And, I tell people don't get the, prepackaged hummus or any of that stuff, because it's basically a petri dish for growing bacteria. And you'll see that if you leave it in your refrigerator after you've opened it and used it, it doesn't take long for things to start growing there. So, the fresher your food, the less exposure you're going to have to that. But honestly, we're probably all colonized to some degree with these gram-negative organisms. And some of them are like H. pylori, which people may know as being associated with ulcers, Klebsiella, which is a hospital-associated infection quite frequently. And that's one that we've seen in John's samples repeatedly, Klebsiella. And then Mycobacteria and Haemophilus influenza are two organisms that we've found in our Parkinson's machine learning from the fecal samples that can also produce these inflammatory.
So those are specific to Parkinson's, though.
Those are specific to Parkinson's, although so Mycobacterium avium paratuberculosis is actually quite closely correlated with Crohn's and colitis. And we're actually doing some work with Dr. Tom Dow to bring a new probiotic to market that is specifically targeting Mycobacterium avium paratuberculosis. And so we're hoping to get that out maybe by the end of the year, but
okay.
Yeah, so, and there's some overlap there. So
maybe before we go any deeper into all this stuff, maybe explain a little bit about this, this kind of conglomerate of scientists and researchers that you've built up. No, because really, I think I started off the episode by saying, you went from being a business person to being this uber researcher, but I would love to explain to the audience that this isn't just you doing this stuff. Like
Yeah.
you've actually connected with and are, what I think is one of your superpowers is your ability to bring different people together from different areas and get them thinking differently. Even talking about this island retreat thing you're talking about for 40 people who are 40 researchers in the space who are willing to take all the knowledge they think they have about Parkinson's, leave it off the island, and come in and be willing to whiteboard a whole bunch of new ideas and new thinking. So please tell us a little bit about the BioCollective so that people understand who we are when you're saying we.
So I founded the BioCollective back in 2015 after reading Martin Blazer's book about missing microbes and the first paper connecting the two different phenotypes of Parkinson's to different profiles in the gut bacteria. And so from that, I just kind of started targeting people who had expertise in different areas that we were looking at in the microbiome, whether it was microbiologists or neurologists or infectious disease people. And I over the course of this 10 years have developed this kind of quirky little mixture of about 10 or 15 researchers. Some of them were researching Parkinson's. A lot of them were not, but I could see an overlap in their research, like, a researcher who was looking at non-tuberculosis mycobacteria. And I hounded him for 3 years. But over time, as those people have started connecting with me, I do a lot of posting on LinkedIn too about scientific papers and unusual connections. And I actually last December got the connection to this Dr. Barry Ninham in Australia. And we formed this little cluster. It's Dr. Ninham, it's Stephanie Seneff on the Glyphosate, it's Laszlo Boros on the deuterium, it's Petra Dorfsman, who's a naturopath who's looking at all these pieces. And, I've got a MD with a company that measures oxidative stress, his equipment for measuring oxidative stress. And then, of course, I have my relationship with Morley that looks at minerals. And I just start sort of pulling all these different people together that look at things in a different way and, aren't necessarily Parkinson's people, because the way we've trained our medical professionals, it's a very narrow lane. And if you really talk to people with any disease, not just Parkinson's, if you actually listen to them, they often will have many of the causal factors and connections they can go back to. So even beyond, the scientific details of looking at stress, this stressor happened and then I got sick. So, people can connect these dots that medical professionals don't necessarily listen to. So I like to sort of pull the patient in, and then all of these, whether it's a biochemist or a infectious disease doctor, or Dr. Dow is actually a retired eye surgeon who now studies autoimmune disease. So
wow. Yeah. So you're really, you're turning the model over on its head a little bit, because you're saying, sure, if you're studying Parkinson's, I'm interested in talking to you, but let's talk to all these other guys and see how their work can be playing into this. Like, I think that's fascinating. Okay. I interrupted you. Let's go back to the LPS story. So we have gram-negative bacteria as they get so gram-negative bacteria and, as they get broken down, the cell wall, which is made up of LPS, which we also call endotoxins. They're one in this. Those are interchangeable terms in this podcast, guys. Those endotoxins are being linked, and I'm going to let you go over all of the different things that they do. But where we were is saying that these endotoxins can be used in animal models to induce conditions such as type 2 diabetes, Alzheimer's, IBD, which includes Crohn's, colitis, and all the others IBs, and MS, and obviously Parkinson's as well. So pick it up from there. Thank you.
So, well, I had been looking at these gram-negative bacteria for quite some time, but actually Dr. Ninham, had a brilliant epiphany, I would say, because John was suffering again from another bout of being exposed to COVID, and he would get these dramatic swings in pH, essentially, or what felt to him like pH, because he was a runner. He was a marathon runner. And he said it feels like lactic acidosis, but then he would kind of swing back the other way to alkalosis. And we were trying to figure out how to deal with that. And, this connection with Barry, talking to him also about the Parkinson's stool and this very dense colloidal mass. I can't describe to you the difference in a Parkinson's stool and somebody else's stool. But, he essentially tied in a dot that basically the gram-negative bacteria are battling the good bacteria, and they produce an enzyme that then kills the good bacteria. They spill out calcium and potassium, which is swinging your electrolytes, and making this very dense colloidal mass where you can't access the nutrition and you don't have the good bacteria that produce the B vitamins and all the hormones and neurotransmitters. They're locked up in this concrete mass, basically. And
wow.
And so, it just made so much sense to me too, because people with Parkinson's, not all of them, but about 80%, I think, suffer from some constipation or severe constipation for anywhere from 10 to 15 years before they're diagnosed. And as it progresses, the constipation gets worse.
Wow. Okay. That's crazy, right? I mean, that's something as seemingly relatively innocuous. Although, again, constipation is another one of those things that is rampant in our society. And we're not saying that constipation causes Parkinson's, but somehow it's tied into this progression in these people, right?
Yes. And if you just think about it, it's waste. And so if it's trapped in your body, I have a book about this thick. It's called The Comprehensive Book of Bacterial Protein Toxins. And,
boy, your reading list.
Yeah. When you start looking at it, it's like, okay, the longer that waste sits in there where they're able to produce all these toxins, the more your immune system is having to deal with these toxins, which, at some point it just kind of gives up the ghost and says, I can't do it anymore.
Right. Well, or it just gets overwhelmed because of everything else that's going on. Okay. So we have now, let's say we have a scenario where we have an increased amount of LPS or endotoxins in the gut. And we're talking about, when we talk about the gut, we're talking about the small intestine and the large intestine. And that's going to be relevant in a minute when Martha talks to us about some experiments that were done with fecal transplant. But before we do that, let's talk about what these LPS or endotoxins do in the gut.
So, they're very inflammatory, but they also activate the vasoactive intestinal peptide, which I think most people think of that as a positive, but it's, if you get anything overactivated in the body, it's upregulating this inflammation and ultimately leading to a loss of barrier integrity of your gut lining. And so then, these inflammatory, the debris, the endotoxin can cross over into the bloodstream and it can go anywhere. So, you could have endotoxin in your arthritic joints. So really anywhere that you've got inflammation, once that barrier is kind of breached, you're going to have circulating endotoxin. And so that's one of the things, because I was very interested in endotoxin and inflammation as it relates to Parkinson's. With our probiotic, we did a clinical trial in diabetes instead of Parkinson's because diabetes has a lot easier endpoint measurements.
Yeah.
But one of the things I wanted to study there was serum endotoxin or serum lipopolysaccharide. So we could see if our probiotic was having an impact on that. And then we also looked at that in the microbiome. And that was one of the metrics in both instances that changed significantly, improved significantly. So that translated for me, even though we haven't done a clinical trial in Parkinson's, that explained why it helped my husband when I first made it and would potentially help a lot of other issues where there is this endotoxin inflammation.
Yeah. Well, and of course, the other thing that bears mentioning is if, the saying goes, if you have leaky gut, you have leaky brain, right? That blood-brain barrier becomes compromised along with the gut barrier. And now you've got real trouble. And I don't know if you've even gotten that far yet to look at, are those endotoxins playing a role in the brain changes that you're observing in Parkinson's disease or Alzheimer's or?
Yeah. I mean, I'll say yes, but like part of the issue, and there's been a false focus in Alzheimer's on amyloid beta and in Parkinson's on alpha synuclein. Both of those are what are called antimicrobial peptides. So they're basically trying to trap and clean up the debris. But I think what you have when you've got these issues with the barriers is, you're not able to clean out the trash, or it's like being backed up on the freeway. There's so much trash, that you can't get it off the off ramps.
Right. And it's interesting you mentioned, I mean, it's a very relevant point, especially in the case of Alzheimer's with the amyloid plaques, because of course you've got this medication now that's been approved that's supposed to break up the amyloid plaques. And you've got I think you have an entire crew of researchers saying that is a really, really bad idea because you're basically disabling the one defense mechanism that the body has, blaming it for the problems. And now you're going to re-release all these toxins back into the system.
Right. Exactly.
Yeah. Which is a bit frightening, unless if they'd also come up with a way to bind the toxins that they were releasing and remove them, which is a whole different kettle of fish. So let's keep going with this. So Dr. I haven't seen his name in writing, so I keep messing it up in my head. Eneman? Kind of like Eminem?
Niddam. Niddam.
No, that's me.
Oh, sorry. Ninum. It's Ninum. It's close.
It's kind of like Ninum, only with N's instead of D's.
Yeah, with N's instead of a D. Ninum. Sorry.
Well, it's close enough. Yeah, now I will remember it.
Yeah.
So Dr. Ninum. Yeah. So let's talk about his work a little bit more. So he's basically on the hunt. He's saying these endotoxins. So he has a new hypothesis around the role that endotoxins are playing. And is he only looking at Parkinson's, or is he looking at all these other conditions as well?
Well, so he basically has a much larger overhaul of biology and physics. The biology and physics of the body and how things are working that have really been misinterpreted up to this point. He was the founder of the Department of Applied Mathematics at Australia National University. He's doing a series of educational videos right now that should be out before too long, kind of explaining that theory. But in the process of, excuse me, connecting with him on this, he got interested in Parkinson's. And so, I don't know, let me get some water.
Take a minute. Yep.
He got interested in Parkinson's. I think because the person who introduced me to Dr. Ninum was actually somebody who followed me on LinkedIn.
No
and
kidding.
said, you need to meet this guy. And we just started going back and forth, and he was bombarding me with his research, which I was reading and sending back questions. And we started connecting the dots on Parkinson's. And that was right before Christmas last year. And, we're back and forth with each other, almost daily.
Wow. That's awesome. He's your new BFF.
Yeah.
Actually, GBFF,
Yeah.
Geek BFF, the best kind. Okay, so let's. Do you want to? Is there more on this you want to explore with the with people? Like, so basically, what we're saying here is we need to get on top of this whole. Oh, well, let's talk about the fecal bacteria experiment that basically started pointing to the fact that the gram-negative, like endotoxin story is not only playing out in the large intestine, but it's also playing out in the small intestine.
Yes. So there have been two fecal transplant studies in Parkinson's. And for people who don't know what that is, they take a healthy donor and they basically put their stool into the GI tract. And one of those came from the bottom up, so more like an enema type or colonoscopy type delivery. And the other came from the top down. And the one that came from the bottom up was not successful. But the one that came from the top down was successful in changing the biomarker or the endpoint measurements of improvement. And if you think about it, like H. pylori, which is this urease producer that that's often in the small bowel. So, and a lot of the microbiome research is only looking at colonic bacteria. It's not really looking at what's in the upper GI tract because it's difficult to get to that. But I think, Dr. Bill Davis is probably the biggest speaker in terms of talking about the increase in small intestinal bacterial overgrowth. And he thinks maybe 70% or more of people in America now probably have some level of small intestinal bacterial overgrowth. And that you do not want those colonic bacteria up in the small bowel. The small bowel is where you absorb your nutrition. It's in that environment, you want it to be more acidic. And those good bacteria, the lactobacillus, the lactic acid bacteria are part of what, produce those acids that kind of keep the bad guys out. But, once they've got a foothold, they are actually alkalizing that environment. And, another kind of interesting sidebar on the Parkinson's note is I take a lot of notes when I meet people with Parkinson's. I can't tell you how many people with Parkinson's I've met who were taking proton pump inhibitors for, 5-10 years before they were diagnosed with Parkinson's. And it's like, no. There's this kind of over prescribing of proton pump inhibitors, thinking that acid reflux is not enough acid. But essentially, you need an acid pH to close that valve. And if you don't get the valve closed, if it doesn't get the signal to close the valve, then what acid is in there is kind of spewing up. So it's a misconception of really what's going on. And the interesting thing about that is there was a study where they used a hose that measured the transit time through the Parkinson's GI tract. And part of what they discovered is these valves weren't opening and closing properly.
Right. Well, isn't the use of PPIs because there's a misunderstanding that the belief is there's too much acid, but actually there's not enough acid. So the food is fermenting and now it's popping up.
Yeah.
And the thing with PPIs, and it's funny, I've tried to have this conversation with a couple of friends of mine who don't want to hear it. But the challenge with the PPI is the perception is it fixes the problem, where all it's really doing is suppressing the symptom. You'd be better off taking digestive enzymes until you don't. And by the way, maybe cutting out the booze, changing the diet, reducing the stress when you eat, all those really boring things. But people are running out buying incline beds. They're taking their PPIs. But as far as they're concerned, it's perfect because they get to drink their wine, eat the food that they want, and think that they're sleeping at night in a sitting up position kind of thing. It's sad in the sense that, you've got a part of the medical establishment that's allowing this narrative to play out that, we can fix that for you. And you don't have to change anything. where, from what you're saying, not only is it not fixing the problem, but could it be opening the door
and making
to a host
it work.
of other issues, right? Because chronic use of PPIs is also linked to an increase in heart attacks. It's an increase of osteoporosis. I mean, those are just the two top things that pop into my mind.
It even says on the package you shouldn't take it long term, but they prescribe it long term. So it's kind of crazy, actually.
Well, wasn't it developed initially just for 6 weeks maximum?
Yeah, I think it was.
Because like in the case of an ulcer, maybe you do need to alter the pH of the environment to allow healing to take place. And I think maybe that's what they were originally designed for. And now instead, to your point, you meet people who've been on PPIs for 10 or 15,
decades.
However many years. Yeah. So, okay. So folks, if you're on a PPI or someone you know is on a PPI, let's just say that what you really want to do is solve the problem and use it strategically for a short period of time to help your body heal if necessary, or give your body the space to heal if necessary. But using it as the solution is not going to give you the results you're after.
The best results, certainly not long term.
Okay, so PPIs seem to be a pre-existing issue for the Parkinson's crowd. And I mean, we're not saying that if you're on PPIs, you're going to get Parkinson's disease, but what we're saying is that it can be one of the contributing outcomes when you've got all these other factors that are also in place for the Parkinson's patient. Now, you had mentioned something to me when we were talking before the episode about the effect of cold was it on the LPS in the gut?
Oh, yes.
You're saying now John's eating with an ice pack on his belly. And I thought that was so fascinating, right? Because you're in this world where you're throwing anything at the wall and you're like, oh, they do really well in heat. Well, what if we made it cold? What would happen then?
Well, so this was actually an idea of Dr. Ninham's, because he said at physiologic body temperature, so 37C, they produce the urease, but below 37C, they won't produce the urease. And so he said, why don't you try an ice pack on his belly when he eats and put an ice pack on his belly at night and when he goes to bed. And so we started to do this, and the kind of dramatic swings in blood pressure we were getting, all of that has gone away. So he had some blood pressure days that were like 58/38.
Super low.
Super low. And
that's the VIP overactivation you're thinking, right?
Yeah.
Or tied in part to that.
So that has stabilized, and it's a relatively simple hack, but it also got me thinking, all these people who are doing cool pools and cold showers. And so that's also sending signals to the microbes. So not just to your cells in your body, but it's signaling the microbes and changing their environment when you get cooler.
Yeah. So would you have John think about doing doing cold plunges? Would he do that?
Yes, we've actually been talking about that. I mean, I take a cold shower every day, and I actually kind of like it now. But I haven't gotten him to commit to, plunging himself down into the deep, dark cold. But I think
it's an interesting concept.
Very beneficial. Yeah.
Yeah. Well, I think it would be different in the sense that, getting into a cold plunge is going to it's going to get into the tissues at a much deeper level than a cold shower.
Right.
Right. And then the next level over, I wouldn't even say up, because again, it's different, is cryotherapy, where you're stepping into a chamber where they're dropping the temperature down to some insane, like I think the last time I did a cryo session, it was down to minus 189 degrees or something ridiculous like that. So you're only in there for maybe 2 minutes, or maybe 3, right? But it would be an interesting exercise to try to gauge, the ice pack on the belly versus the cold plunge versus the cold shower versus the cryo. Which of those is going to affect the microbiome more?
Right. Yeah.
Right.
That would be a very interesting study, I think.
Yeah. And comparatively, relatively easy to do. I'm sure somebody's got some kind of temperature probe they can stick up
Right.
deep enough.
Probably. I mean, it is interesting too, the kind of localized temperature of the body. Like people think the body temperature is kind of consistent everywhere. And one of the things, another sort of experiment we were doing over the course of trying to figure out what was going on with the long COVID and everything, was taking his temperature multiple times a day. And his forehead temperature in 3 different spots was typically 2 to 3 degrees below normal. So that made me wonder too, after, this ice pack biohack, is that the body's attempt to lower temperature, but it's unable to lower it in the localized area of the gut?
That's so interesting. It is interesting to think things that we think are pathological, are negative. Is it possible that it's the body trying to compensate somehow for something? And yet we think, oh my God, your temperature's too low. We have to pick it up. Or, it's like a fever in a way. Fevers are tricky because there's a physiological reason why we develop fevers. It activates enzymes and certain parts of the immune system. And yet, as parents, we see our children's temperature go up. They're achy, they're sad, they feel miserable. The first thing we want to do is drive it down.
Right.
And there's a point, of course, when you get into certain temperatures where you do need to drive it down because it becomes dangerous.
Right.
But these starting to get into deeper understanding about what is the body's ability to do this if we let it run its course, kind of thing.
Right.
Not that it would fix Parkinson's on its own, because we know it can't. We're talking about a system that's overwhelmed with so many different things going on, right?
You've gotten, I think, like if you look at, as I look at Parkinson's over this 22 years, it's an increasingly stressed system over time. And a lot of that, I think also, and I'll have to look if this organism is a gram negative, but I bet it is Vibrio, because there's a group in Finland who came out and said that is the cause of Parkinson's. I don't think that's the case. But
seems a bit simplistic.
it's a hydrogen sulfide producer, and hydrogen sulfide in small amounts in the mitochondria in the body is actually an important signaling molecule. But of course, too much hydrogen sulfide gas will kill you. So, the body is very interesting in its way of regulating things. And I've gotten more and more as I've studied the microbiome papers. Like the earliest papers were like, this is elevated. It must be the cause of this disease. And if you really start to dig a bit deeper into the function of those organisms, you're like, it's there for a reason. It's, it's the terrain, and it's handling a problem, an environmental exposure or a stress hormone or something. It's trying to balance the system out in some way. And so I think there is a danger in just looking at something and saying, okay, that's the cause and let's go kill it.
Well, even H. pylori, isn't H. pylori naturally present in the body? Like there's a degree of H. pylori that you need. I remember reading a study once when I was in school where they'd eradicated H. pylori completely, and then these people got obese. And, I think they get stomach cancer too. I think it keeps you from getting stomach cancer. Yeah. So it serves a purpose, but in a very specific ratio. Like it's like, I think for researchers, for humanity, we try to look at things as black and white because it's so much easier when something is good and something is bad. And the fact is that what I think people are learning increasingly as we go, it's about nuance, and nuances on top of nuances that it's taking us so long to kind of unpack. So let me ask you a question, because this topic is on the tip of everybody's brain, and I think you mentioned it already. Do you think that AI is going to accelerate your learning in some way? Like, have you started tapping into that yet? Because it seems to me that you talked about machine learning, which I guess is AI to some degree, but do you foresee that AI might help to start tease out some of these nuances more efficiently than the human mind can?
I will say yes and no. So,
Okay.
you have to have the right kind of prompts and the right kind of out of the box ideas to feed it, to get it to think outside the box. But again, like, there's also a danger to it because it's fed by data sets. And so let's just take Dr. Ninham's premise that the vast majority of, the biology is wrong, and that's the data set you're working from. Then if you use AI for that, you're just going to perpetuate, which we do already with how we fund things. We perpetuate the same things that, may not actually be accurate, which is why we want to have this meeting where we say, okay, let's put everything over here that we think we know and say, maybe that's not right. And, that partly came from seeing a cardiologist who has recently come out. He had a friend with Parkinson's and he was very involved in drug development, and his friend asked him to look at Parkinson's, and he came back after studying all this stuff and said, dopamine is toxic to the neurons. And he shows how it's toxic to the neurons. And he has, I think he's going into phase 3 clinical trial of a different therapeutic for how to treat the problem, which is totally out of the box, came from a cardiologist, not a neurologist or a neuroscientist. Yeah. And, it's pretty amazing. And, but we've been giving people dopamine for however many years. And then, when they die, we do an autopsy and we say, well, the neurons are dead. Well, what if the neurons are dead because the drug that we gave them for all these years is what killed the neurons?
Well, and isn't the dopamine kind of, it works for a while and then it doesn't?
Yeah.
Right? Like it, and maybe, how interesting, wow, like how crazy is it? Because you keep upping the dose. And as we were just saying, the right amount of something is beneficial, and you go over the line or under the line, it becomes less so.
So H. pylori actually eats dopamine. So there's research showing, people who have more H. pylori in their gut, if they're taking dopamine, will often have more off time where their medication isn't working. So they take more medication, and the more they take, the more it feeds the H. pylori. It's like this vicious cycle.
Wow. So, folks, if you're still with us and we haven't lost you somewhere back in the weeds there, the moral of the story is, I think that, to try and step away from the black and white view of what's good and what's bad, and to be open to the possibility that what we think we know, we don't quite know yet, to be, to try as best as we can to step away from these so-called solutions like PPIs that solve a problem that ultimately is really making, it's affecting the microbiome, it's affecting all these different pieces of the puzzle that and it doesn't have to be Parkinson's. It can be so many other different conditions that fall out. And I think, we're still learning, humanity is still learning that we cannot block or seriously, intervene in body systems and not have consequences on the other side. Like, even if we think we're solving one problem, we tend to be creating another. You mentioned earlier that, and I can't remember if it was during the podcast or before the podcast, but you mentioned that you could look, that you and or the scientists that you work with can look at a stool sample of a person without knowing anything about that person and tell you if they have Parkinson's disease. Is that true of other conditions? Like, can they also say, oh, this person has type 2 diabetes, or this person has Alzheimer's, or is it specific to Parkinson's?
So in our lab, and that was over the course of about 3 years of collecting samples. Parkinson's was the only thing that they came to me and said specifically, I can tell that this is a Parkinson's sample. And wow. It just came down to how we process our samples. So we process samples into,
you're looking for something. Yeah.
And we couldn't process a Parkinson's sample with a syringe. We had to use a caulk gun because of the consistency of the stool.
So this is this colloidal mass you're talking about.
This is the colloidal mass.
The wax.
Yeah.
Wow. And so were there specific strains of bacteria that they were finding or not finding? Like, do you know that? Do you know
Well,
what
that's
it
actually
is that
what
they
we
were
did.
finding?
Yeah. So we did that in the machine learning work we did with Artigen. And, some of the key biomarkers came from Haemophilus influenza and mycobacteria. But then we also published a paper with Sarcus masmanian about metabolites. And there's a new meta-analysis that's looking at like 6 or 7 different Parkinson's studies of the gut microbiome. And of course, the headline said, vitamin riboflavin and I forget one of the other B vitamins, might cure Parkinson's, which is again a big stretch. They pick out some little piece out of the study, but if you go back to the microbiome, those good bacteria that are getting killed by the bad guys, the good bacteria are the ones that make those B vitamins.
Okay. So yeah, which doesn't mean that giving the B vitamins is going to cure Parkinson's, but it's going to make up for a deficiency.
Might make up for a deficiency while you get your gut in order. So,
okay. So out of all this and and I'm asking this because you have your husband and he's the guy, he's guinea pig number one at the end of the day. Are you finding that there's certain interventions that you're applying in his case? And again, every Parkinson's person isn't going to be necessarily the same, but are you finding that there are specific interventions that you're applying with him that seem to be making a difference? And have you tried those with other people that you're in contact with in the Parkinson's community and seen effect?
So I've actually just started getting some people with Parkinson's to try the ice pack because it's, we just figured that out in the last 6 weeks or so. We're still trying to figure out the diet. And because you can feed both good and bad bacteria with the same foods. So part of just trying to figure out that whole thing is what foods cause problems. And we do see that, but he actually did start doing a lipid replacement diet because, those cell membranes are also where a lot of that signaling is going on. And so, he has been focused on, like eating mackerel and sardines and, trying to get it from foods, much more than supplements, but, really
but
looking.
There's some supplements. Yeah. There are some supplements that seem to be uniquely positioned to, like, even I'm sure runny egg yolks are playing phosphatidylcholine.
Right. So we actually put egg yolk in his protein shake in the morning, and he did start taking the fatty 15.
Yeah.
So
and did that move the needle for him at all yet? Or
well, I didn't see that moving the needle, but I think that was also, he started at about the time we were really trying to hone in on these pH swings. So, you can throw too many things in the mix.
What about things like phosphatidylcholine supplements? Like, are you finding that is that part of his lipid replacement strategy?
That's part of his lipid replacement strategy.
Mm-hmm. And did I introduce you to Dr. Dayan Goodnow with the plasmalogens?
No, but I have been following him, and actually, what's really interesting is Dr. Ninham. So, Dr. Goodnow's work explains a lot of what Dr. Ninham's new kind of theory of biology. There's a great episode recently with someone talking to him. I'll send it to you if you haven't seen it. That really explains what's going on and connects dots for me to Dr. Ninham's work, because sometimes Dr. Ninham is like way up here. And,
but Dr. Goodnow is, I will introduce you to him, because I do think that he should be one of the 40 people on that island if you can get him out there.
Yeah, that would be great. I would love that.
Really interesting. Well, because when you're talking about lipid replacement, what he talks about are very specific phospholipids that are an inherent component of white and gray matter.
So also the plasmalogens are made by bifidobacteria. And bifidobacteria are much lower in people with Parkinson's and also in the people who had poor outcomes in COVID. And then another friend of mine did a study in before and after COVID vaccination, and it specifically targeted and killed the bifidobacteria.
No kidding.
No kidding.
That's nutty. Yeah, you heard it here first, guys. Plasmalogens for the win, and bifidobacteria, right? So now, okay. So now in the time, look, I mean, we could, you are this universe of information, Martha. Like it's really, somebody's going to have to give you some kind of a doctorate or PhD or something at some point. But in the meantime, you've also been hard at work with your team of scientists working on specific probiotic strains that you've been developing, and I would imagine have been evolving over the last number of years with a view to helping your husband. But again, as we were talking about earlier, it can be so helpful for so many people. And so I want to say there's 3 different probiotics that you got, or are there 5? There's 5. And the one that sticks out in my mind, because when you said this to me, it like blew my brain a little bit, was that you have a strain of bacteria in at least one, if not all of them, that actually has been shown to break down glyphosate in the gut. And we don't, we're not going to go down the glyphosate rabbit hole right now, but whatever you believe in the world, guys, glyphosate's not our friend, and it is pervasive. At this point, it's gotten into the environment. It's in the water, it's in the air, it's in the soil.
Yeah. So I have an article coming out in the Weston Price Journal this quarter that's about tying what's going on in food, a study we did in cabbage and the loss of cell wall structure, to what's happening with our collagen, and tying that to glyphosate because of this shikimate pathway that there are almost 9,000 known enzymes that are in the shikimate pathway. And those are all coming from bacteria. So if we're killing those bacteria, obviously, it's a challenge for us, especially with the aromatic amino acids. But so the original formula I made is called Sugar Shift. I made it for John based on some research at a conference that showed that the sugar alcohol mannitol could stop the aggregation of the proteins that were clumping. And, I came back and studied mannitol chemistry, and we built a computational model where we could essentially build a team that would produce more of what we wanted it to produce together as a team for a period of time than any strain would do by itself. And so we took that concept beyond Sugar Shift and made these other. So we have an immunity formula, we have a heart cardiovascular support formula, we have one for restoring the gut after antibiotics, and we have one for sleep. But the Sugar Shift formula, that's the one I made for John, where we could see over the 120 days when I originally made it, how it was improving his gut and changing the biomarkers in the gut. And then we went on to study it in diabetes, which is also interesting. Parkinson's and Alzheimer's are often called type 3 diabetes, which is an insulin resistance of the brain. And so we went on to do a clinical trial in diabetes and essentially showed that it moved fasting blood glucose, postprandial blood glucose, something called HOMA-IR that measures insulin sensitivity, a reduction in serum LPS, a reduction in triglycerides. I mean, it was just a home run all the way around. And I think in a lot of it does have to do with, this inflammatory LPS, reducing the LPS and kind of restoring balance to the ecosystem.
Wow. And so is that the kind of thing that you would run for 3 months and then take some time off? I mean, unless you're John and you've got issues like someone like that. But let's say for a run-of-the-mill person who's trying to stay ahead of this stuff and understanding that many of us have some component of this going on, whether we like it or not. Would you do like a 3-month run and then step away and then come back to it kind of thing? Or
no, I do have people who, will do a 3-month run and come back to it. But, most people who have metabolic issues, I think a lot of that is due to the glyphosate. And of course, we have our strain that remediates the glyphosate is in every one of our formulas. But I think it is also one of the drivers in that sugar shift formula, because, we saw an increase. I think it was like 900% increase in the detoxification, cytochrome P450 enzymes for detoxification. And so
wow.
Unfortunately, you really can't get away from glyphosate, even if you're a really clean eater. And in the article that I wrote for West and Price that ties into this study we did with Dr. Don Huber on cabbage, essentially the organic cabbage lost its structure because they used conventional poultry manure on it. And
it has glyphosate.
And it had glyphosate and bound up the minerals. And so, these conventional manures are widely used in organic agriculture, and people don't really realize that. So
how is that even possible? Like, how does that qualify? Like, you would think that organic agriculture would have a clue.
It's a dirty little secret.
It's a dirty little secret.
I think from back it might be as far back as 2001, because I don't think there's enough organic manure, to
buy
provide
a couple of cows,
to provide I have a friend who's sort of a policy person on the food side, and he says it's the dirty little secret that nobody wants to talk about. So,
wow. This is where those biodynamic farms, and maybe there's a problem there too, but in the biodynamic farm, the principle being that you have an you're right. Nurturing an ecosystem. You're not growing cabbage,
right?
I believe,
exactly,
right?
Exactly.
And so you have I remember in Costa Rica once going to to this place. They'd won some kind of National Geographic award. The only way to get in there was on a whitewater raft, and they had a pigsty. And they were feeding the pigs the food, leftover food and whatever, like actual food. And then they were using the waste from the pig to drive power somehow. And like they just had this fully integrated system because they were so isolated and they couldn't access things from the outside. And it's almost like it's the farms that are going to take this kind of approach where we're building an ecosystem. We're trying not to bring in the fertilizer from somewhere else because, right? I think if you were recreating that ecosystem and you had cows working the soil and pooping in the soil and capturing the carbon and doing all the things, look, I'm a city person talking about things I know nothing about. I harbor no illusions about that. But from the little bit that I know, it seems to me that the people who are having the most success in this space are the ones that are really getting into this whole hog. Like, completely.
That's where we were 100 years ago. And, we've got to figure out how to get back closer to that. Because this chemical input agriculture is killing the soil microbiome, and everything is connected. I tell a story. Back in 2016, I went to a microbiome conference in London, and I was walking back from dinner, and I turned down this really dark street, and there were no lights anywhere except this big billboard in front of me, and it said everything is connected. And I was like, oh, I get it.
Oh my God. That was a sign.
I was like, okay, yes, it is.
Message received.
Yes.
I got it. Wow. Well, Martha, conversations with you always require a fair chunk of nootropics coming in so that I know that my brain is awake. But, the work that you do continues to be so groundbreaking precisely because you are not a doctor and a scientist and a researcher. And I would say now, I'm not kidding when I say at some point somebody's going to give you some kind of honorary something or other, because you've jumped in with both feet. You've managed to put your arms around people from different disciplines and help them to get to a place where they're thinking and conversing with people they wouldn't have been otherwise. And these are problems that they have to be looking for out of the box thinking. And maybe like this Dr. Ninham, being willing to question the models, like tenets of biology that we take as fact. And maybe we got a couple of things wrong in there that's throwing everything else off. And being willing to kind of take that monster apart, like it's got to be really scary. You've taken your spaceship to the moon, something broke. You have to take the damn thing apart and put it back together again. That's pretty scary, because what if you can't get it to fly again? And yet maybe that's what needs to happen here.
I like that. Yeah.
So
that's what we're going to do.
And well, it's what you're doing. And the case in point also, I think, is that your husband, 22 years in to a really scary diagnosis, I think is probably doing, is he there?
Yeah, he's doing pretty well. The long COVID really set him back, and then all this sort of figuring this out. But it's been an interesting ride, and he's been a real trooper. He can sort of.
He's fasting now, right?
It's like, he's fasting now, so he's.
How much fun can you possibly pack into a day, John?
Yeah, he just finished his online biking class. So
excellent. Okay, well, you're getting into that ketotic state, no problem, any minute now.
Yeah.
Okay, so Martha, as we wrap up, let's point people to the BiotiQuest line, which I think is, so you've got the sugar shift, the immune formula, the post-antibiotic formula. I didn't realize you had that. Somebody just asked me about that recently. And would that be appropriate for a child?
Yes. I mean, all of these
usually
are
probiotics
with strains that have been looked at in children. We haven't studied children, but most of the strains have been studied in children.
Right. And then we have sleep, and then we have cardiovascular.
Yes.
Great. Okay. And then, folks, if you want to do some shopping, you can use code NAT15 and it'll save you some money on your formulas. But in the meantime, I think what I love when people are buying your stuff is they're supporting your work also. Not only are they supporting their health, but at the same time, you're supporting this incredible body of work that I think we should all be super grateful that you've taken on.
Thank you so much, Natalie.
Yeah. Well, this has been a total pleasure. And what's your website and how can people follow you?
So the website is www.biotiquest.com. So that's BIOTIQUEST.com. And if somebody's particularly interested in Parkinson's, I have a blog, and that is marthasquest.com. And then if you really want to know about collecting poop, you can go look at the BioCollective.com. And we're on BiotiQuest is on Instagram and Facebook and
all the places.
And we also have a Sugar Shift Challenge group. So if anybody wants to join that, they can come to the Sugar Shift Challenge group, and we have different people come in and talk, and then I talk about the research that we're doing. So every couple of weeks we have a call and take questions and open it up for education. So.
Oh, I love it. And where's the group hosted, on Facebook or somewhere else?
The group's hosted on Facebook. So you just request to join the group, and we'll get you in and get you the information on how to access the calls.
Love it. Thank you again. Have an amazing day, and good luck with your long fast.
Okay. Thanks so much.
My pleasure.